Hello everyone, I am Tannu Sharma from BSc Chemistry Honors final year. Today I am here to record a video for visually impaired students on the topic fat, oils and detergents. Let's start. Fats, oils and detergents. Oils and fats are widely distributed in nature, both in animal and plant kingdoms. In animals, they are present under the skin and in muscles, but in plants, they are mainly found in the seeds. Some important examples of fats are butter, lard, tallow, beef, etc., while groundnut oil, cottonseed oil, olive oil, palm oil, coconut oil, sunflower oil, soybean oil, linseed oil, sesame oil, etc. are important example of vegetable oils. Fats and oils are one of the three major constituents of our food, the other two being carbohydrates and proteins. In fact, fats and oils serve as energy reservoirs for the animals. In human beings, only a few hundred grams of glycogen can be stored, which can barely supply the body's energy need for about 12 to 18 hours. In contrast, large amount of fats can be stored, which can supply the body's energy needs for about 8 weeks. Besides this, oil and fat serve as raw materials for a number of industries such as soap, paints, varnishes, and vanaspati ghee, etc. Natural fats. The fats obtained from animal sources such as butter, from milk of cows and buffaloes, etc. Lard from hogs and tallow from sheep, goats, etc. are called natural fats. This name is simply given to differentiate these fats which are obtained by hydrogenation oils. Edible and non-edible oils. Oils such as groundnut oil, sunflower oil, soybean oil, rapeseed or mustard olive oil, sesame oil, which are used for cooking purposes, are called edible oils. While oils such as cottonseed oil, linseed oil, castor seed oil, and moa oil, which are used in soap, paints, varnishes, and liquor industries, are called non-edible or industrial oils. On the basis of iodine values, oils have been classified as drying, semi-drying, and non-drying oils. Industrial oils may include essential oil and mineral oils. Essential oils such as rose oil, jasmine oil, lavender oil, peppermint oil, etc. are volatile oils isolated from plants. Essential oils may be hydrocarbons, alcohols, aldehydes, ketones, etc. For example, peppermint oil contains menthol as its chief constituent. Essential oils are mainly used in perfumes, cosmetics, and in pharmaceutical products. On the other hand, mineral oils is a mixture of saturated and unsaturated hydrocarbons and not esters or triglycerides. They cannot be saponified. They are called oils simply because of their physical appearance. They are non-edible and are mainly used as fuels. Triglycerides, composition of oil and fats. As stated above, fats and oils are triesters of glycerol with higher aliphatic monocarboxylic acids, fatty acids. In other words, they are triacyl glycerols and are commonly known as glycerides. Fats and oils may be represented by the formula. This formula, where R dash and R double dash may be same or different alkyl groups, fatty acids, with only a few exceptions. All the monocarboxylic acids isolated from fats and oils are straight chain compound containing 3 to 18 carbon atoms. Further, with the exception of only C3 and C5 acids, all other acids found in fats and oils contain even number of carbon atoms. The chief saturated fatty acids present in oils and fats are lauric acid, malicylic acid, palmitic acid, stearic acid. Besides saturated fatty acids, unsaturated fatty acids containing one or more double bond in cis orientation may also be present in oils and fats. The chief unsaturated fatty acids in oils and fats are oleic acid, linoleic acid, linolenic acid. Classification of glycerides. The three fatty acids in glycerides may be same or different. Therefore, glycerides are classified as simple or mixed glycerides according as they have the same or different acid residues. For example, tripalmitin or glyceride tripalmitate, simple glyceride, alpha oleo beta palmito alpha dash stearian, mixed glyceride. Glycerides are further classified in saturated and unsaturated glycerides according as they contain saturated fatty acid residues or unsaturated fatty acid residues. For example, triestyrene, saturated triglyceride, triolene, unsaturated triglyceride. Both simple and mixed glycerides are found in natural oil and fats. In fact, oils and fats are complex mixture of glycerides along with small amounts of glycerides. Chemical difference between oils and fats. The main difference between oils and fat is the proportion of saturated and unsaturated glycerides. Triglycerides with higher proportion of saturated acid residues such as palmitic acid, stearic acid, and are solids at ordinary temperature and are called fats, while those with higher proportions of unsaturated acid residues such as oleic acid, linoleic acid are liquids at ordinary temperature and are called oils. Melting point of glycerides. As stated above, fatty acids have one or more double bonds, having less stable cis stereochemistry. For example, oleic acid has one cis double bond at C9, linoleic acid has two double bonds at C9 and C12, while linolenic acid has three cis double bonds at C9, C12, and C15 positions. These cis double bonds have vital biological importance in the solid state. The molecules of saturated fatty acids fit closely in the crystal lattice due to their zigzag tetrahedral structures. On the other hand, cis unsaturated fatty acids have a band at the double bond and hence do not fit closely, thereby lowering their melting points. Chemical properties. Fat oils, diesters of glycol shows all the reactions of simple esters. In case of glycerides, contain unsaturated fatty acid residues. They also show the usual addition and oxidation reactions of alkenes. Some important reactions of fats and oils are given below. Hydrolysis. Fats and oils are readily hydrolyzed by treatment with superheated steam, mineral acids, or alkalis. फैट और ऑयल को की जब हाइड्रोलिसिस होगी 500 के प्रेशर टेम्परेचर पे और प्रेशर पे तब ग्लाइसरॉल और फैटी एसिड मिलेंगे. हाइड्रोलिसिस बाय सुपर हीटेड स्टीम और मिनरल एसिड्स gives a mixture of fatty acids and glycerol. However, when hydrolysis is carried out by alkalis, glycerol and the salt of fatty acids are formed. फैट और ऑयल को रिएक्शन कराएंगे जब 3 NaOH के साथ NaOH के 3 मोलिक्यूल के साथ तो ग्लाइसरॉल और सोडियम साल्ट मिलेगा. सोडियम साल्ट that is soap. Since the salt of higher fatty acids thus formed are used as soaps, the alkaline hydrolysis is commonly called saponification. In the digestive system of humans and animals, fat oils are hydrolyzed to glycerol and fatty acids by a number of enzymes called lipases. Hydrogenation. Oils which contain a higher proportion of unsaturated glycerides add on hydrogen in the presence of finely divided nickel as catalyst to form solid fat. For example, triolene की hydrolysis पे मिलेगा triestyrene. This process is called hydrogenation or hardening of oils. It is similar to catalytic hydrogenation of alkene and involves the reduction of double bonds um, present in unsaturated glycerides to form saturated glycerides. This process is extensively used for the manufacture of vanaspati ghee from groundnut, peanut, sunflower, and other edible oils. Hydrogenation is never carried out to completion but is stopped as soon as the fat of consistency comparable to ghee is obtained. The completely hydrogenated fat are too hard to be useful as kitchen shortenings. The main advantage of hydrogenation is that as compared to oils, fats, hydrogenated oils have better storage qualities and do not become rancid easily. Hydrogenolysis. Conversion of conversion to alcohols. Fats and oils on treatment with hydrogen at high temperature and pressure are in presence of copper chromate as catalyst undergo reductive cleavage to form glycerol and long chain aliphatic alcohols. For example, triestyrene in presence of CuCr2O4 in high temperature and pressure gives glycerol plus an octadecyl alcohol. This splitting of a fat or an oil to glycerol and a higher long chain alcohol by hydrogen is called hydrogenolysis. The long chain alcohols thus produced are used for manufacture of synthetic detergents. Transesterification. Fats and oils can be converted into simple esters of carboxylic acids such as methyl, ethyl esters, etc. The transesterification. It involves the treatment of a fat or an oil with the large excess of a suitable alcohol in presence of acidic or basic catalyst. For example, alpha oleo beta stereo alpha palmitin. plus CH3OH in presence of CH3ONA gives glycerol and a mixture of methyl oleate, methyl stearate, and methyl palmitate. The process of trans-esterification is quite useful for the large-scale preparation of long-chain fatty acid and long-chain primary alcohols of high purity. For this purpose, the mixture of methyl esters obtained by trans-esterification is subjected to fractional distillation to separate the individual esters. These, upon hydrolysis, yield fatty acids of high purity. Alternatively, the individual methyl esters are reduced to get long chain primary alcohols. Addition of halogens. Like alkenes, unsaturated glycerides add halogens across the double bond to form addition products. The addition of iodine is usually carried out by treating the fat or the oil with iodine in presence of mercury chloride as catalyst. Smetrioline की तो आयोडीन और HgCl2 की प्रेजेंस में रिएक्ट करेंगे तो हमें मिलेगा ट्रियोलिन hexa'iodide. Since the amount of iodine used is proportional to the number of double bonds present, therefore this reaction is used for determination of extent of unsaturation in a given fat or the oil. The density. When fats and oils are exposed to warm air and moisture for a long time, they develop a disagreeable smell and taste. This process is called density and involves the hydrolysis of esters to produce fatty acids and oxidation at double bonds to form short chain acids and aldehydes. These short chain acids and aldehydes are volatile and have offensive smells, therefore, they impart unpleasant odors to oils and fats. So, density is of the following two types. Hydrolytic rancidity. This type of rancidity is caused by the liberation of lower fatty acids by hydrolysis of triglycerides. For example, when butter is exposed to warm air and moisture, the hydrolysis of the glyceride in butter yields butyric acid and other volatile acids with unpleasant odor. Oxidative rancidity. This type of rancidity is caused by oxidation of unsaturated triglycerides by air to form short chain acids and aldehydes having unpleasant smell. It is believed that first that ester linkages are hydrolyzed to yield unsaturated acids which undergo oxidation at the site of double bonds to produce short chain acids and aldehydes. For example, oleic acid की oxidation होगी तो Largonic acid or azelaic acid मिलेगा. Analysis of fats and oils. Fats and oils are extensively used in a number of industries. Therefore, it is essential to check the quality of a given fat or an oil. This involves the determination of a physical constant such as melting point, specific gravity, refractive index, etc., and chemical constants such as acid value, iodine value, saponification value, Richard Missile value, etc. Some important chemical constants are described below. Acid value. It is defined as the number of milligrams of potassium hydroxide required to neutralize the free fatty acids in 1 gram of fat or an oil. The acid value is determined by dissolving a known weight of a given fat or the oil in a pure neutral alcohol and titrating against standard pH solution using phenolphthalein as an indicator. Saponification value. It defined as the number of milligrams of potassium hydroxide required to completely saponify 1 gram of fat or oil. Iodine value defined as the number of grams of iodine that will combine with 100 grams of the fat. Richard Missile value RM value is defined as the number of milliliters of 0.1 NaOH required to neutralize the steam volatile fatty acids obtained by completely hydrolysis of 5 grams of fat or oil. Industrial oils or vegetable origin drying oils. Certain oils such as linseed oil, tung oil, when exposed to air in thin layers from hard and tough water insoluble solids. This process is known as drying, and such oils are called drying oils. Oils like olive oil, groundnut oil, etc., which do not dry on exposure to air, are called non-drying oils, and those which are dry slowly, such as cottonseed oil and semi-drying oils. Chemically, drying oils contain a high percentage of unsaturated glycerides, as shown by their high iodine values. On the other hand, non-drying oils have low iodine values, while semi-drying oils have intermediate iodine values. For example, drying wells have iodine values above 150. Non-drying wells have iodine values less than 100, while semi-drying wells have intermediate iodine values. Unsaturated glycerides contain linoleic acid and linolenic acid as the unsaturated fatty acid residues. These acids contain 2 and 3 isolated double bonds respectively. In general, drying oil containing the unsaturated glyceride with conjugated double bonds dry more rapidly than those containing isolated double bonds. Mechanism. The actual process of drying does not simply involve removal of moisture or evaporation of solvent but involves complex changes. It is believed that the reactive allylic hydrogens present in unsaturated glycerides are first attacked by oxygen to form hydroperoxy compounds, which means then combine with the allylic hydrogen of the other glyceride molecules from peroxide bridges. Soaps, substances like soaps and synthetic detergent, which concentrate at the surface of the solution or interfaces from surface films, reduce surface tension of the solution and help in removing dirt and dust by emulsifying grease are called surface active agents or surfactants. The fats and oils commonly used for soap manufacture are tallow, lard oil, olive oil, linseed oil, and mauve oil. Soaps contain 12 to 18 chain atoms have good cleansing action. Synthetic detergents. These days, in place of soaps, the substances which are being largely used as cleansing agents are synthetic detergents. As the name suggests, they are obtained from purely synthetic chemicals as compared to soap, which are derived from chemicals which are obtained from natural sources like oils, fats. In fact, synthetic detergents are sodium or potassium salt of long chain alkyl hydrogen sulfates or aryl sulfonic acids. Unlike soap, synthetic detergent can also be conveniently used even in hard water. This is due to reason that calcium and magnesium salts of detergents like their sodium or potassium salts are also soluble in water. Hence, synthetic detergents do not form curdy white precipitates with hard water. Further, they can also be used in acidic solutions. However, synthetic detergents have one disadvantage. Unlike soaps, they are not completely biodegradable and cause water pollution. सिंथेटिक डिटर्जेंट्स आर फॉलोइंग थ्री टाइप्स अनायनिक डिटर्जेंट्स इसके भी और दो टाइप होते हैं एल्काइल सल्फेट्स और एल्काइल बेंजीन सल्फोनेट्स कैटायनिक डिटर्जेंट्स एंड थर्ड इज नॉन आयनिक डिटर्जेंट्स अब है composition of a detergent cake. A cake of detergent contain about 20% of active detergent and an equal amount of sodium sulfate to make up the bulk of the powder. A further 3 to 50% of sodium tripolyphosphate sodium STPP is added as an additive. It coordinates with Ca2 positive and Mg2 positive ions present in the hard water and thus enhances the cleansing efficiency of the detergent. Other ingredients include sodium perborate, which act as the bleaching agent, some optical whiteners, and fluorescers. Organic compounds which make yellow clothes appear white, and some foaming agents. Detergent pollution. Detergent having branched chain hydrocarbon chain cause pollution in rivers and other waterways. The reason being that side chain stops bacteria from attacking and breaking the chains. This results in slow degradation of detergent molecules leading to their accumulation. Since unbranched chains are more prone to attack by bacteria, therefore, in most of the detergent used these days, the branching is kept to a minimum so that detergent become easily biodegradable and pollution is prevented. The second serious environmental problem is caused by phosphate additives (STPP), which are discharged into rivers and lakes from sewage system. As such, phosphate is not a pollutant but is actually a fertilizer. This excess of phosphates promotes the growth of water plants, which in turn deplete the water of available oxygen for fish and other aquatic animals. As a result of want of oxygen, water animals die and rot. In other words, lakes become full of dead animals and vegetation, and hence cease to act as a source of potable water. Potable water. In the view of these environmental hazards, government of many countries have passed a law to reduce the use of phosphate additives in detergents to mitigate this source of pollution. Cleansing action of soaps and detergents. Although soaps and detergents contain two characteristics group water soluble hydrophilic and oil soluble lyophilic or lyophobic group lyophilic or lipophilic group. As a result, one end of the molecule of a soap or detergent tends to go into oil phase and other tends to go into the water phase, with the net result that the material soap or detergent concentrates at the surface of the solution or interface. The dirt is generally held to a dirty surface by thin film of an oil or grease. When the dirt surface is treated with the soap solution, the non-polar hydrocarbon chain of the soap or detergent dissolve in oil or grease, and the carboxylate group of the soap or sulfonate group of the synthetic detergent is held by surrounding water. This lowers the surface tension between water and grease. As a result, a stable emulsion of oil in water is formed. When the surface or the cloth is mechanically scrubbed, the loosened dirt particles are adsorbed by colloidal soap or detergent particles and ultimately washed away. Thank you.